This is another viewer's special request. How to prepare potassium dichromate, starting with relatively OTC compounds. Our source of chromium is this fairly pure chromium 3 oxide known as chromate oxide, as you can see here. It's a very fine green powder which finds use in pottery and glass making. We're starting with 25 grams of chromium 3 oxide. Now for our potassium hydroxide. We're using 30 grams, which is a 3.2 molar ratio to the chromate oxide. You can use sodium hydroxide here, but if you do, the sodium dichromate form is more soluble. You'll need to add the potassium salt later on to get it to crystallize out. And now for our oxidizing agent. Just as for the permanganate preparation we did a few videos back, we're going to use potassium nitrate for this. We've got 25 grams here, which is a 1.5 molar ratio to the chromate oxide used. We put all three starting ingredients into a blender and converted them into a well-mixed powder, as you can see here. There's still a few lumps, but nothing serious. Now you'll need to work quickly because the potassium hydroxide will rapidly absorb moisture. Here's our trusty stainless steel food shaker. Not exactly stainless though after what we've used it for. Let's get the mixture in. Here we go. The container is about half full. So we'll balance this on the gas burner and heat it strongly. It doesn't take long before the mixture inside starts to melt. Pretty soon it's all melted and starts to bubble away. And soon after the mixture appears to thicken again, and bubbling begins to eject material out of the container. So we put a lid on the container to prevent this, and continue to heat. Soon the mixture inside the container becomes a white solid paste. And you can see a hint of orange color around the outside of the mixture. We put the lid on the container and then applied full heat for 15 minutes non-stop. At the end of this time the mixture inside was quite a yellow color, as you can see. Using some tongs to hold the hot metal container, we used a spatula to break up the solid inside and give it a thorough mix. Then we put the lid on again and gave it another 15 minutes constant heating on full power. Then we slowly allowed the container to cool to room temperature. Strangely, the contents of the container appeared almost red in color, but when taken out, either on cooling or exposure to air, they turn green again like this. We scraped out the contents of the steel container into a large beaker. It's changed color to a light green. We added about 50 ml of boiling water to the steel container and the remaining solids dissolved and suspended very easily. Then we poured this into the beaker containing the rest of the solids. We added about another 25 ml of hot water, making up to a total volume of about 100 ml. And then placed on a hot plate in order to keep the liquid hot, and gave a good stir to break up any lumps of material. Now time to filter the hot mixture. The filtrate, as you can see, is a beautiful intense yellow. We then transferred the green filtered solid back into the beaker and added a further 40 ml of boiling water. Then after heating and stirring again, We filtered more intense yellow filtrate. Still a few yellow crystals visible in the filter though. So we added a little more boiling water to get all of our product dissolved out. As you can see, there wasn't much unreacted chromic oxide left, perhaps just a few grams. Here's our filtrate, which contains our product, potassium chromate. We put this on a hot plate with a small stirrer and heated in order to evaporate down a little. We also did a little test to check the pH of this solution. Strongly alkaline still. Chromate is the chromium-6 species which is favored in alkali solutions. However, in acid conditions chromate changes to dichromate. This has reduced down a little bit, and we're starting to see some crystals forming on the surface of the hot liquid. Here we've got some concentrated hydrochloric acid. We're now going to slowly add this to the solution in order to take the pH down until it's strongly acid. Careful doing this because the neutralization produces some heat, and you don't want the toxic chromate jumping out of the beaker. As you can see, the solution turns a dark color. There's also an orange tint forming, which is our dichromate. We've added about 50 ml of hydrochloric acid now. So let's test the pH again. It's difficult to know if the red is the color of the solution or the reaction of the indicator. But looking at the edges where the liquid is diffusing through the paper, it's strongly acid. So we covered up the mixture and chilled it in the fridge for about an hour. Dichromate is not very soluble in cold water, but the other salts present in solution should stay in solution. And sure enough, after an hour, we've got lots of brilliant orange crystals formed in the liquid. We filtered these off. Most of the dark color is staying in the filtrate, leaving the orange crystals behind. We then washed the crystal twice using 20 ml each of ice-cold water. This got rid of the residual dark color. Then we got them as dry as we could on the pump. The filtrate dish still contains some dichromate, but we'll wait and see what our yield is like before we decide whether to process this further. We couldn't get the solid completely dry, but we got it to this stage and then we placed into an oven at 120 degrees C for a few hours in order to dry completely. Here's the product. 18 grams of potassium dichromate as a dry fine powder with a beautiful bright orange color. This represents a 74% yield on the starting chromium oxide, which is great. We decided not to further work up the dark-colored filtrate, although you could evaporate it further and try to produce more crystals if you wanted to. Well, this is good, but because the powder is very fine and not nice crystals, the color is slightly more yellow. Let's make some of that beautiful orange crystalline product like you would obtain commercially. To do this, we simply recrystallize the potassium dichromate from boiling hot water using about 35 to 40 ml in this case. In the boiling water, the solid dissolves readily, forming a dark red colored solution. Now switch off the heat and allow the beaker to cool as slowly as possible. The slower the cooling, the larger the individual crystals. Pretty soon orange crystals will start to form in the solution. Once the beaker is at room temperature, Chill it down to get as much solid out as possible. Then filter, wash with a little ice-cold water, and dry thoroughly on the pump. Recrystallization is quite efficient. You can see there's some dichromate in the filtrate, but not that much. Here's our final commercial quality product. Beautiful orange crystals of potassium dichromate. We use dichromate in some of our other videos as an oxidizing agent for organic reactions. To check these out to get some interesting ideas on what you can use it for. Thanks for watching.